Hey guys, welcome back. So the biggest question is what's going to be on the AP exam. Now, we can't be dogmatic about it. We really don't know. We don't know, but we do know that the questions have already been set. Okay, now usually you got 6 questions, okay, and there's pretty much 5 types, okay, of questions that I categorize them as. You can get rate accumulation, you have a graph analysis, you have differential equations, which you can use implicit differentiation in that, um, and then you got particle motion, and you got area and volume. Now area and volume for 2020 is not going to be on there, so that helps us a lot to kind of fine tune it. Now what I've noticed is every year they give you a rate accumulation question every single year, and there's nothing to say that this year would be any different. It's just fundamental to calculus. So what I want to share with you guys is what would I do if I were in your shoes. That's the best way I can answer the question, and this is no absolute, but we want to just kind of fine tune what we're gonna see. Now, knowing that this year is a little bit different, and remember the AP teachers and the program, they're all on your side. They want you to pass, they want you to succeed, but by no means do they want to just hand it over to you. Okay, and you guys have been doing a great job of getting ready, so just keep it. But now we're gonna fine tune it, work smarter, not harder, and see what we can just kind of focus on. And what you notice here, one thing I noticed, check it out. You see, this is a related rate question in 2019. They gave you 2 functions. Boom. Same thing here. They gave you a rate. Boom. 2018. 2017, same thing. Something going in, something going out. Boom. Okay. But look at 2016. They gave us a table and it's a rate. Okay. You have a rate of water being pumped in here. Water is being removed by the tank, modeled by R of T, and they give you a table. See, in 2016, they gave you a table. 17, 18, 19, they didn't. So you know what? They're due for a table. So I'm just thinking, you know what? Just make sure you're ready for this. And it's interesting because they do throw in that table time and time again, for you guys to kind of use Riemann sums. So as soon as I see a table, I see, okay, they're going to ask me for an R prime. They're going to ask me for Riemann sum, usually left hand, right hand. Middle, I think I've seen middle once, okay, but just be ready for that. Now, how would I study for this, okay? How would I study for this? Well, guys, just, go ask. The more you explain, the more you retain, okay? So how many, okay? How many, what do? You integrate a rate from what? Whatever's going in. What is the average number of fish? What does that mean? Keyword. Boom. Okay, the integral 1 over b minus a. That leave the lake. Okay, what is the greatest number of fish? Okay, that means boom. I need to incorporate everything. Okay, I need my general equation. Okay, how do I find greatest number? Is talking about your max, your min. As soon as you know that, okay, that means you need your first derivative set it equal to 0. Critical point, and then you go ahead and find your values. Okay, so you can see, but first for accumulated rate, you need the general equations. Derivative, set it equal to 0. E of t has to equal L of t. Boom, you get your critical point. So now what do I do? How do I find the maximum number of fish? Right here. You got to find the beginning, the middle, the end. These are the end points. This is your critical point. Okay. Is the rate of change in the number of fish increasing or decreasing? You're comparing the rates. But when you see this, the rate of change in the number of lake increasing or decreasing, okay, that's talking about E prime of t and L prime of t, okay? And this one I didn't put. But that's how I would do it, guys. Now, this is 2019. So if you have any questions on that, go back to that video and take a look at it. But the purpose of this video is to fine tune what we're looking for. And how am I going to study? Boom, accumulated rate. Okay, when it says how many fish, what do? Integrate. When it says average number of this, what do? Okay, go back to 2018. What does it say? How many people? Boom, take that integral. Okay, let me see here. Minimum right here, you see? How many people, when is it the minimum? What do? Okay, same thing. Get your general equation. Okay, take the derivative, set it equal to 0. Okay, so that's how I study. And the more you explain it out loud to somebody, the better off you are gonna about retaining it. Okay, 2017, the rate accumulation question again. How many pounds of bananas? Integral. There you go, from 0 to whatever. F prime of 7. How do you do that? Okay, this is the question I was talking about. Is the number of pounds of bananas increasing or decreasing? That seems to come up a lot. So what do? You compare the rates going, in this case, going in and going out. Okay, and so that's what's here. See? So going in minus going out. This is going in minus going out, right? That's why it's minus. And what? So this means it's decreasing. And this is from 2017. So you have more specific questions on that. You just look at that video. And then it says how many pounds of bananas are on the display table. You see that? Okay, at t equals 8. And a lot of times, guys, you see the total, you see, in the initial plus what's going in plus minus what's going out. So, I mean, I am almost 100%, 99.99% sure that you're going to get some type of rate accumulation, a real life word problem, because it's just fundamental to calculus. I mean, it just is. And every year, if you go back and look at from last year, previous, you're always getting that. And another thing I noticed also, okay, is another problem you always get on this AP exam is a graph analysis. They always give you a graph to analyze. Look at this one, 2019, 2018, 2017, 2016, 2015, 2014, and it just continues on. So, I mean, you can't say for sure, of course not, but look at the pattern, and they continue. Now, the only thing I will say, it's kind of interesting because 2019, 2018, they started doing something different. They started adding this, they added this, piecewise with now the semicircle, but then they asked something different. And, they asked for the integral. So I'm thinking, okay, just kind of be ready for that. And look at, they added something else. Evaluate the integral from 2 of 2f prime of x plus 4. So they had me do a little bit of calculus by hand there, okay? And then here, in 2018, and again a piecewise, and they added this quadratic in there with g of x, okay, and look at the integral, okay, which I had to separate the integral, okay, but essentially, guys, they're asking the same thing. Look at, they're asking for the maximum value. So ask yourself, okay, if they give me a graph analysis, how do I find the maximum value? Boom, derivative, set it equal to 0, critical point, number line. This is my derivative, and usually that's what they're going to give you. Derivative, critical point, boom. You can make a number line, okay? And then you got to find, once you get your critical point, right? If they're asking for a maximum value, all right, that means it's at, where is it at? Here, at -1. So you got to check the beginning, the middle, the end. Okay, then how do I find the value from the derivative? You integrate it. Right? You integrate a rate, you get an amount. All right. And so you're just talking to yourself. If you can Zoom with each other, help each other out, get together. I know some states, they've eased restrictions. So just get together. The more you explain, the more you retain. 2018, same thing. Okay, if f of 1 equals 3, how do I do that? How do I find f if they give me the derivative? You take the integral. And then what do? You do your fundamental theorem of calculus. The fundamental theorem of calculus, guys, you're going to see it is just what it is. It's fundamental to our calculus, period. Boom. When they say point of inflection, what does that mean? Oh, second derivative. What do I got to do? I got to analyze the graph. Okay. Oh, when is it both increasing and concave up? When it says that, what does it mean? What am I looking for? Okay. And you're analyzing the graph. The more you talk, the more you speak, the more you'll retain. 2017, look at same type. F of -6, f of 5. What do they give me? A derivative. So how do I find it? Boom. You integrate, okay, right? Fundamental theorem of calculus, right there, fundamental theorem of calculus. Okay, on what intervals is f increasing? I got to look at the graph, and I got to know, okay, these are my slopes that are positive, so it's increasing from -6 to, what is that, -2? And then from 2 to 3, 4, 2 to 5, okay? And then what happens what do I do when they ask me for a minimum value? So you just continuously quizzing each other, testing each other. And look at, they're asking the same thing. Does G have a relative minimum, a relative maximum, or neither? What minimum, maximum, same thing. Derivative, set it equal to 0. Find your critical point. Analyze the number line. Okay. And same thing. How do I find the minimum value? What's the difference between a relative minimum and an absolute minimum value? Okay. One of them is just, okay, I got the point. But the other one is I got to find the actual value at that point. Okay. And just analyzing it, guys. So same thing. Maximum. Look at that. Concave down. Increasing. And I don't want to go back too far because we want to just kind of fine tune it to see, okay, where are they going? But guys, hopefully this helps. And I know I made videos about the graph analysis, and you know what? I see graph analysis come up every year, and I've seen rate accumulation come up every year. If it was me, okay, and I was deciding which tests were going to be on there, you mean, I see these guys have it hard year. They've had it tough. You know what? Give them the fundamentals of calculus. One, that word problem that has a real life scenario. Two, the graph analysis, which has always been there. Now, yeah, they can't throw an oddball in there, okay, like they did in 2019, and I hope they don't do that this year, okay. But I mean, that's just my thinking. Of course, we have to be prepared, just have it in the back of your mind. But for me, I'm focusing, okay, that rate accumulation problem, make sure I know that graph analysis problem, but pat down, okay. Make sure I know this table question because 2019, 2018, 2017, they gave me a rate accumulation, but there wasn't no table. So now let me see, they might give me a table. Just make sure I know how to do the table. Particle motion, okay? Particle motion, 2009 you got one. 2018 you got one. 2017 you got one. But then 2016, 2015, you know what? And then 2014 you didn't. So, I mean, particle motion is another, biggie, right? And so you just go back, okay, what does it mean? How do I find acceleration? Okay, what does this mean? What's the difference between speed and velocity? Okay, I want you guys to how do I find position from velocity? Okay, how do I find acceleration? How do I find the position of the particle when they give me velocity? What is this difference? What does this mean as opposed to what does this mean? So these are fundamental questions to particle motion problems. Okay, how do I know when a particle is speeding up or slowing down? Okay. And if you're going in your head like, man, I don't know, those are good questions. That's where to start. Okay. When is the particle moving to the left? Okay. What does it mean to travel in the same direction? All right. You see how find the acceleration. Is the speed, you see that? Is the speed increasing or decreasing? They always ask that, guys. Find the position. Okay. Well, how do I find position from velocity, right? See, those are fundamental questions that they always ask for particle motion. Okay, look at this, 2016. Is the particle speeding up or slowing down? Boom. Well, how do I figure out speeding up, slowing down? Velocity at that point, and then acceleration at that point. Okay, when does it change direction? What does it mean to change directions? Find the position. How do I find position from velocity? Total distance. How do I find total distance? Total distance is the absolute value. Okay. So all these questions, I'm just asking myself questions, and I'm forcing myself to, you know what, I have to answer these. And if you can get together with a Zoom session or, just hammer it out, boom, and just get your little stack, rate accumulation, get your little stack, graph analysis, your next stack, particle motion problems, all particle motion problems, and you're looking at it. Okay, I see, they're asking the same thing. What does this mean? What does this mean? I mean, and if you had those down pat, I mean, you can't but not get a decent score. I know they might throw in a weird one, an oddball like they did in 2019. I really, really hope they don't. And that'd be cold shot if they do, because everything's been just crazy this year. But just what happens when they give me a table? Boom, as soon as they see a table, okay, they're going to ask me to find the slope somehow. Look at the first question. V prime of 16, what do you do between 12 and 20? Boom. You use the values. See, look at it again. What does this mean? Approximate the value of this using a what? A Wright-Riemann sum. All right. Let me go back to this one. What does average velocity mean? What does average velocity mean? Look at it. That's average value. This guy comes up a lot for particle motion. Okay. And in the other ones as well. Okay. You see that? Find all the values of t for which the speed, you see, of the particle is 2. Okay. Write an expression involving the position. You see how it keeps coming up the same? Look at letter D. Is the speed of the particle increasing or decreasing? So see, now we're talking about what are we fine-tuning our efforts to? What are we looking at so we can just be better prepared for these questions? Okay. And then the other one that is going to come up is differential equations. Okay. Now, differential equations are kind of iffy too. Now, in 2016, they had it. 2017, they didn't. 2018, they did. Last year, 2019, they did not. My guess would be this year, they would. I mean, I don't know for sure, but that's just the pattern, all right? And they say, you know what? Last year we didn't give a differential equation. This year we will. I mean, they're just human beings, and they just want you guys to be well-rounded. But look at what they're asking you. They might ask you to graph the slope field just a little bit. Okay, so a few points. But look at what they ask you. Write an equation of the line tangent. What does that mean? Okay, to find the particular solution. All right, they're going to ask you to separate these variables. Okay, remember when we separate them. All right, find that constant. And it's interesting because these suckers, when you separate them and you have to find the particular solution, they're worth a lot of points. Probably like 6 points. Okay, same thing here. 2015 differential equation right here. Okay, what do they ask for? Determine the concavity. And you know what? When I did this video, and I completely forgot to do this one, the second derivative would be positive, because over here the x is negative, the y is positive, is concave up in the second quadrant. But look at what they ask you. Relative minimum, relative maximum. Okay, what does it say? Find the what? Particular solution of the differential equation at f of 2 equals 3. What do? You got to separate them. Okay, you got to separate them. All right. Let me see, in 2015, this is another one. Interesting. 2015, they gave them 2. Question 4 and question 6. That was interesting. I could definitely see them giving you something like this. Write the equation of the line tangent. You see that? y1, y minus y1. Find the coordinates of the curve at which the line tangent is vertical. Evaluate the second derivative at these 2 points. So interesting. They keep asking for the second derivative. They ask for the line tangent. They ask for the particular solution. You know what? Look at this. Is interesting. This is 3 questions, A, B, and C. In 2013, it was only 2, A and B. What does it say? What does it say? Write the equation for the line tangent. What about this one? Find the particular solution. Okay, so they're asking the same type of things, guys. Look at 2000. This is 2010, but I know it's old, but it's still useful. Write the equation of the line tangent. Okay, use the line tangent to approximate what? F of 1.1. Find the particular solution with the initial condition. So when they ask you, if I'm studying, okay, what does it mean? What does it mean to find a particular solution? Boom. Separate the variables. Integrate. Find the constant. Okay. What does it mean to use a tangent line? What does that mean? Write the equation of the tangent line. What would I do here? What would I do there? And you just continue to just ask those questions, those fundamental questions, and to help you guys. So hopefully you're starting to see it. You're starting to see, working smarter, not harder, to be able to see, rate accumulation, graph analysis, particle motion, differential equations. Somebody asked me, is there going to be an optimization? There hasn't been an optimization problem in, gosh, I don't even know if there's ever been an optimization problem, which is not to say it's not important, but that's just not what the AP focuses on, or these calculus teachers feel that it's important to focus on. Okay, not to say it's not important, but there's so much more that's more they want you to focus on. So optimization hasn't been there for, gosh, at least 10, 15 years. The last related rate question that I found was in 2008. Not to say that it's not important, but it just hasn't been. So we're following the pattern, and this is what we see: rate accumulation, graph analysis, differential equations, area volume, which is not going to be on here, and then particle motion. So hopefully, guys, that helps you. I wish, I had some time to, my calculator, some of you have been asking about the calculator. Oh man, with everything that's happening out, my school shut down, I can't get in, and it's hard. I wish I could have my TI-89, my TI-84 to show you guys. But you know what? Help each other out. Help each other out, and you know how to. Maybe you guys can make a video on how to use a TI-89. Just post a question. Hopefully somebody will make a quick little video and help each other out, guys. You're all in this together. We all want to succeed. We all want to do well. All right, guys. So lastly, I just want to thank you, wish you enough. I hope these videos have helped you guys and feel encouraged. Get a good night's rest and do your best. That's all you can ask for. Just do your personal best, guys. And I commend you, and I can't wait to hear from your successes, guys. All right, guys. Good luck.